Hello, and welcome to this video on graphing inequalities in two variables. This video is meant to be a review. It will move decently quickly. You probably, if you're here, have seen this before and just need a little bit of a refresher. There is no formality here of using test points. If you've done that in the past, you should be to a point where you should be able to refer to the symbol to know which side of the line to shade instead of doing a test point. So let's just get started with some examples here, and hopefully this will come back to you like a flood. Okay, so we've got y is greater than x plus 1. So to be able to make this graph, I'll have to graph just y equals x plus 1 and then shade one side of it. We see that the y-intercept is 1 and the slope is 1, so I will start at 1 on the y-intercept, go up 1, right 1, up 1, right 1, up 1, right 1. Okay, and drawing this line, you need to know if it's solid or dotted. So you notice here it's y is greater than, and I hope you guys remember that greater than or less than, use a dotted line. Greater than or equal to or less than or equal to, use a solid line. Similarly, if you were just making a graph on a number line, they are analogous to using an open dot versus a solid dot. Okay? If you're looking for a way to remember that, I'll just separate the two, and if you notice, the ones on top take less ink to draw than the ones on bottom, and that's true for every symbol up there relative to each other. Okay, so I am going to use a dotted line here because it's just greater than, not greater than or equal to. Okay, and here's my dotted line, and now for the moment of truth to shade the solution. Excuse me. So where we have a greater than, it would make sense for us to shade above the line. Keep it simple. Greater is above, less is below. So here, we're going to shade above the line. Now don't lose sight of what you've done here. What you've done here is you said that every point up above the line, not including the line because it's dotted, but above the line, every one of these points has an x comma y. It's an ordered pair. If you actually took that ordered pair and plugged the x in and the y in, this would become a true statement. That's what you found here. Every point above the line has that nature. Okay? So, now, that being said, let's go to the next example. 2x minus 4y is greater than or equal to 8. Again, you should notice here that this will be done with a solid line because it's or equal to, which means points on the line will satisfy the solution as well. Now, here, I'll probably spend a moment just to get y mx plus b form. Okay? Greater than or equal to. We're subtracting 2x from both sides. And now I'm going to divide by -4. So be careful with that because you're dividing by a negative. Now you should know the rule that when you divide by a negative, you must flip the inequality symbol. Similarly, if you multiply by a negative on both sides. Okay? So here we go. Y is now less than or equal to -2 plus 1/2 x, making our y-intercept -2 and our slope 1/2. So I'll start at -2 and put a dot, go up 1, right 2, up 1, right 2, up 1, right 2. With this, like I said earlier, I'll be graphing this with a solid line. Now, the little trick here is, where do you look for the symbol? You got a greater than symbol, and you got a less than symbol. Well, greater than or equal to, and less than or equal to, I should say. Well, you constructed this graph off of this statement, so it's better to focus on this symbol. Might be a little odd. You might say, well, shouldn't I be using the original problem? Well, they're both the same, don't forget. It's just that here you can tell in terms of y, it says y is less than or equal to, so we will in fact shade below the line. And every point down here is part of the solution set, which means if we plug the x and y values in of any point in this area, you would in fact get a true statement. So, now, we're calling this graphing inequalities in two variables. It should be more called two dimensions, because if you notice here, I'm going to do an example that's only got one variable, but we are going to do it in the Cartesian plane. Okay? The only thing I need to do is graph x equals -4, which you need to realize is a dot on the x-axis, and then a vertical line through that dot. Understanding that the or equal to means it will be a solid line. Okay? So, now, the one thing that this throws kids off with is they see the x and they go, well, the x-axis goes left and right. Shouldn't the graph go left and right? No, because what we're saying is every point on this line has an x value of -4, okay? So you need to realize it's a little reversed in how it feels, but you probably should have learned it already, and that's just a reminder. So now, if we're going to look at graphing the points that are, in fact, greater than or equal to -4, greater than, given the choice of right or left, it should be pretty intuitive to say they're to the right. Okay? And again, what are we saying? We're saying that any point to the right of this line, vertical line through 4, -4, has an x value bigger than -4. Well, if you look here, 4 comma 0 does, 6 comma 0 does, 6 comma 3 does. Again, it's the x value you're looking at to make this statement true. So this is the solution for x is greater than or equal to -4. Now look, I'm going to kind of just extend this. Where does this go? This goes into systems of inequalities. Systems are just when you do more than one statement simultaneously. So I'll do these in color here, okay? And I'll do the first one in red, next one in blue, next one in purple, okay? So we see that we've got y is greater than or equal to -4. So I'll go to the y-axis, graph a dot on -4. And again, although the y-axis is vertical, its graphs are horizontal. So horizontal line through -4. If you notice here when I shade, I'm just going to put a little shading above the line, okay? Just so that I don't put tons of shading on the graph because I'm doing 3 of them. Now you've got x is greater than -2. If you notice here, it's not an or equal to. So I'm going to use a dotted line. It's going to go through -2, okay? And it'll be a vertical line through -2. And greater than shall in fact be to the right of this line. Again, not shading the whole area. What I'm trying to say by that is everything over here is greater than -2, but I don't want to scribble all over my paper because I'm trying to find a final solution, which is where these shaded areas intersect. So now to do the final one in purple, we see that y is by itself, m is -1, b is 3, so I'll start at 3, go down one, right one, down one, right one, okay? And we notice it's or equal to, so I'll need a solid line, okay? Let's need a different color here. So we've got this, okay? It says less than or equal to, so I'll shade underneath of it. And if you notice, we're looking for a piece or area, I should say, where all the shadings intersect, and that should be in fact decently obvious that it's the interior of this triangle, as well as any point on this line, because it's solid, any point on this line segment, because it's solid, but not the ones that are on that line segment because it's in fact dotted. So the solution is excluded from that part of the line. Okay, so that's it in a nutshell. You should be very good at this skill. Practice, tell a friend, enjoy. Bye.